Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today. Consider a 2-year project that, when fully funded at time 0, has a net present value of 350. The decision tree below shows the cash flows of the project when partially funded at the beginning of the year 1, so at time 0, with an option to provide different amounts of funding at the beginning of year 2 at time t equal to 1. This tree reflects two economic states. GE stands for good economy, BE stands for bad economy, in each of the 2 years. For a given year, each economic state has a 50% probability. Here's the picture. So you see that we have a good economy and bad economy outcomes in year 1, and then additional funding decision can be made with different results in year 2 resulting from that, the additional funding options vary depending on whether it's a good year or a bad year, and then the results in year 2 vary by good and bad year. So this diagram is used for the decision, and we'll go over this in just a second. But we also assume that the discount rate is 0% to make the calculations easier. Calculate the value of the option at time t equal to 0. So the value of the option will just compare the outcome if you just pay for the project as is and you get that net present value that is given in the problem, or you do partial funding at the beginning and then you wait for the outcome at the end of the first year, and then you decide what additional funding you do, and then you have the outcome at the end of year 2. So to figure out the value at the beginning, we work backward from the end of the tree. The upper branch, following an information node, represents a good economy, and the bottom branch a bad economy. So we start with the top branch. At time t equal to 1, we have choice to invest 700 or 500. These represent negative cash flows because you spend the money. If we invest 700 and the second year has a good economy, the project generates a cash flow of 1,600. If we invest 700 and the second year has a bad economy, the project generates a cash flow of 1,000. The expected value is the average of the two, because the probabilities are 1/2 for each of the possible outcomes. So it's 1,300 for the second year, with an expected net gain of 1,300 minus 700, so it's 600. Similarly, if we invest 500 and the economy in the second year is good, the project generates a cash flow of 700, and if bad, a cash flow of 200. The expected cash flow is the average of the two, so it's 450 for an expected net loss of 50 because we invest 500 and on average we make 450. So we should invest the 700. That's the better of the two choices, including the year 1 cash flow, which is given we're talking about good economy right now. That cash flow is 1,300. A good economy in year 1 leads to an expected value of 1,300 plus 600, which is 1,900. That 600 comes from the 1,300 minus 700, the expected result of investing 700 in the second year. So 1,900. And now we perform the same type of analysis on the bottom branch. The expected value of cash flows at the end of a second year with an investment of 300 is 700 for a gain of 400, and an investment of 0, the expected cash flow is 200 for a gain of 200. Hence, the investor will spend 300 at the end of the first year, and with the year 1 gain in a bad economy, the value of this branch is 500 plus 400, so 900. The expected value at the very beginning is the average of this 900 and 1900 from the upper branch, which is 1400. And the net present value equals the amount, that amount, which we just calculated, minus the outlay required to fund partially at the very beginning, so 1000. That's 1400 minus 1000 is 400. And the value of the option is the net present value of the project minus the option, with the option minus that net present value without the option, which we know from the problem. And with the option, the value is 400. We just calculated that. Without the option, the value is 350. That's given in the problem. So the difference of the two is 50. And that's answer B. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.